So today, I'm going to have one more lesson on numbers. Still, there are too many problems. The reason I collect so many problems because the students have trouble with this. I will switch to geometry next class, and yeah, we cannot just always focus on numbers. Okay, this is you know, the billions of problems there. Okay, but as you can see that the weakest area is always basically geometry and the numbers, about numbers. Okay, and those are another topic usually covered by in elementary school. Okay. Okay, so my today most of the problems really relate to the three questions on the numbers. Okay, so my first problem will be the following. Okay, we're talking about what is what positive, not what is, what positive 5-digit number was an 8 in the 10,000th place is a perfect square. We're trying to find the perfect square. Okay. Okay. So a number will be 8, A, B, C, D. Okay, that's a 5-digit number. Okay. Now this is going to be perfect square. Now, how do you find this perfect square? Well, you have to use a scientific calculator first, okay? Because on math counts, you're given a scientific calculator. So what they have to do is it's a perfect, it's a not perfect, not perfect square, perfect cube. I'm sorry about that. Perfect cube is much more difficult to figure. Okay. So what you should do is you do some estimate. Okay. The largest possible value for this type of number is 89999. Okay. The smallest possible value will be 80,000. Okay. So you have the range. So that means the perfect cube is between those two numbers. So that m is going to be the third root of 89,999, and this will be the third root of 80,000. Okay, so then use a scientific calculator to estimate. Then you solve the problem, because when you use a scientific calculator, you end up with 44.881, and that will be 43.08. Okay. Now, without scientific calculator, you have to do some rough estimate. Okay. You will figure out maybe 40. So 40, 40, 40, then it's not good. But 41, 41, yeah, that also works. Okay. So, so you can try. Okay, clearly m should be 44. Okay, because that's only one integer between them. Okay. So my suggestion, if without using scientific calculator, and then use just regular calculator, then just say 40, you know, it'll give a rough estimate. Okay, then yeah, 40 cube, right? 40 cube. You begin with a 40. 40 cube is 4 times 4, right? Right? 4 times 4 is 16. 16 times 4, 64. So it's pretty close to that number. Okay, then you 41, 42, 43, just few steps, and you get the answers. Okay, so finally, yeah, you will still same time, you know, you can quickly get a number. So you have to do rough estimate. You cannot by guessing, you know, well, kind of guessing, trying, but the best way, yeah, there are a couple ways to solve the problem. I don't see which way is better right now at this moment, but you have to do a rough estimate. Okay, that would be very useful. Okay, that's it. All right, my next problem I want to discuss. Okay, my next problem I want to discuss is a number we call a visible factor number if it's divisible by each of its non-zero digits. That's a very strange number. Okay, a number, okay, is called a visible factor number if it is divisible by each of its digits, each of non-zero digits. Okay, if there's a zero digit, then so for example, 102. This is divisible by 1 and divisible by 2. Okay, so it is visible fact. Question is, how many visible factor numbers are there from 100 through 150? Okay, inclusive. Okay, inclusive means including 100. Okay, I think 100 is a visible number because it's divisible by 1. 150 is divisible by 1 and 5. Okay, so how do we solve this problem? This is a 3-digit number, right? You have to say 1AB, right? That's a 3-digit number. And all those digits, okay, think about this is so what is the positive value for A? Okay, the positive value for A is from 0, 1, 2, all the way to 5. Okay, because of 150. B can be any integer from 0 to 9. Okay, and this should be divided by 8, divided by A and divided by B. Okay, now you also have to get rid of this. You have to discuss a case when A is 0, when B or B is 0. Okay. So can you divide them into several cases? Let's try. Okay. It takes it takes a while. Okay. So we have you assume, you have to look at the case when both A is 0 or B is 0. So the first case, you assume A is 0. Let's take a look at that one. Then we decide it. Okay, if A is 0, then 10B is just a 100 plus B. Okay, it is divisible by B, then B can be 0 or not, right? If B is 0, that works, right? So that includes the B0. Okay, and then from here you get 100 equals n minus 1B. I think B can be any of these numbers, right? B can be any of this number because 100, right? So 100 is divided by 0. No, so B is definitely can be 0, right? But 100 divided by 1, 100 divided by 2, 100 divided by not 3, but 4, and the 100 divided by 5. So you list all of them, okay? And it's possible, okay? Okay. So we, you have a, A could be 1, 2, 3, right? It's a few cases. So you only have how many cases here? You have probably 5 cases. Okay. Case 2, A equals 1. So 1, 1, B. That's 1, 1, 0 plus B. That's going to be also MB. Okay. Yeah, let's see who get answers. Okay. So Brian, they have answers. Great. Okay, so you see, take a look at right. So 110 equals n minus 1b. Okay, then clearly, which 110, right, is divisible by, okay, 0 is okay. 0 can no. When b is 0, m is 1. So b0 is okay always. Okay, b is 0. That's fine. Divisible by. So b can be 1. And the 2 definitely, but it cannot be divided by 4, cannot be by 3, so it's 5. 5 is okay, so you get this. Okay, so then when case 3, A equals 2, then you have 1, 2B. Okay, and this is divisible by 2, so immediately you will get this is divisible by 2, right? Because it's a, this is a visible number. So divisible by 2, so B must be even number. You can, yeah, there's a restriction here. So then, and meanwhile, it also should be divisible by B. So that means there are not many choices. I figured out. Then they totally find out B is B can be, I think can be 0, 2, 4, 6, 8. Okay, so this is a, see, look at this. This number should be divisible. B is even, but also should be divisible by 2, divisible by B. Okay, so B could be 0. Yeah, 0 is included, right? 0, it's even. This cannot be 1. Okay, B. Let me check. B's B cannot be 3. B can be 1. Okay, it's 1, 2, 1. 1, 2, 1. Yeah, 1, 2, 1. So yeah, yeah. See, yeah. No, all the other numbers should be excluded. So you have to just look at the even numbers. 3, 5 cannot be that. Okay, remember that. This number should be divisible by 2. So exclude all the other. So even numbers 2, 4, 6, 8. And you find out, you just check that 126 was divisible by 4 or not, right? And then you find out, yes, 120 is divisible by 2. 122 is divisible by 2. 124 is divisible by 4. 126 is divisible by 6. 128 is also divisible by 8. Okay, so you have to check in this video. And then that's what I did. Okay, maybe you have a great idea now. Then the case 4, A equals 3. When A equals 3, you get 3. It can 3B, right? But that should be divisible by 3. if you divide by 3, right? And then implies B is the only choice, B and the 5. Okay. Yeah, 100. Yeah, a number divided by 3, right? The sum of the digits must be also divided by 3. So that is you can quickly determine it's B and 2 and 5. If it's 2, then it divides by 2. If it's 5, then also divides by 5. So you only get 2 quickly. Then case 5, A equals 4. Then a 14B. Okay. Then 140. Yeah, 14B is 140 plus B, and this is divisible by 4. This should be divisible by 4 also, but that implies is divisible by 4 is going to be B should be equal 0, and B equals 4, no problem. B equals 8, but if B equals 8, and that is impossible. B equals 4 is fine. 144 is divisible by 4, but 8 should be excluded. Okay, 140 because it's not divisible by 100. Let's see, 148. Okay, divisible by 4. It's not divisible by 8. Okay, it's not divisible by 8. So that's why. Okay, it's not divisible by 8. Okay, so that's why this should be excluded. And then the last case. Okay, A equals 5, then it's 150 B. Okay, so this should be divisible by 5. Then B is B can be let's see, there's only 2 possible cases here, but let's look at the 150. Okay. 150 is divisible by any of the non-zero digits, right? But the 150 is included. Yeah. And the 155 is not included. That's why I have to exclude. So total, there will be 19 visible numbers, not 17. Okay. So total, you can list all of them. Yeah. Yeah, add them together, you get 5, 4, right? That 5, 4, 9, 9 plus 5, 14, 14 plus 2, 16, 16 plus 2, 18, 18 plus 1, 19. Yeah, 19 problems. But this is a problem usually give you 3 minutes to work out. You have to quickly. I think that's the way you can do. Otherwise, it's a very difficult to figure out the digits. You have to choose of A, because A have only few choices from 0 to 5. Okay, and then you choose one by one, choose the value, individual value for A. Then you look at these, then you can determine the digit for the B. Okay. Okay. Here's another problem we have to divide. Let's look at that simple one first. Okay. We're going to rewrite. Okay. Rewrite A over B plus C over D and E of F such that each variable is replaced by a different non-zero digit, and the value of the expression is 1. All right, so let's see. Rewrite the expression such that each variable replaced by a different non-zero digit, and the value of the expression is 1. We're trying to figure out the value. Okay, so the digits, you can only use the digits to put that. All right, so that means A, B, C, D, E, F should be equal to 1. Okay, A, B, C, D are digits, and they are different, replaced by different digits. So my understanding is that all of them should be different. Okay, now there's a famous identity. Okay, the famous identity is 1/2 plus 1/3 plus 1/6 is 1. Okay, this is a fact, but this does not meet the requirement. Okay, it does not meet the requirement. Daniel Liu, F cannot be 12. The reason is it's not digits. It's already integer. Okay. Okay. So you want to use the digits. Okay, you cannot keep all the ones there. Okay, numerator is always equal ones. All you have to do is you change it to 1/2 is 2/4, and 1/3 is give me 3/9, and 1/6 still keep the same value. That's it. That's easy. All right. All right. Now let's do a 3-minute problem. The 3-minute problem is the following. Okay, I want to try. What is the sum of all the positive 2-digit number, okay, which is divisible by both the sum and the product of the digits. Okay, so that means, okay, that means you have a 2-digit number, right? So the value will be 10A plus B. So you're going to try to solve this equation. It's divisible by its sum, also divisible by its product. So you're going to determine the digits, satisfying those equations. Yeah, you can try this. Okay, I do got several solutions. Okay. Yeah, I got three actually. I got 3 integers. Okay, add them together. Just you don't need to add them. Just find all of them. That's right. Find all the digits satisfy this condition. Okay, because this is on the test. They only want to have one number for each test. That's the reason they ask you to add them together. Okay. Okay. Find how do you find the solutions? Okay, using this equation and use the divisibility. Okay, you have to modify the equations. Okay, there will be 2 equations. 10 minus, there's those 2 equations first to look at. All right. So 10A plus B equals MA plus MB. So that would be 10 minus M A equals N minus 1B. Okay, that's the first equation. Right, and you also have you can also have those 2 equations. Okay, those two equations, 10A plus B equals NAB. Okay. Okay. So that will be 10A equals NA minus 1B. That's one, right? You move B to the other side. And you can also get from this, you can also get NAB minus 10A. So you take A out. Okay, anyway, so from those identities, you can modify, simplify, and continue. Okay, so that's my hint, to think about the possible values. Yeah, that's probably not good enough. But when I look at this is very useful identity actually. Okay, when I look at this identity, I can put it here. Okay, so 10M A equals N minus 1, and the B is replaced by NB minus 10A. And then you see this A is canceled out because A never be 0. Remember that first A. So you get very important identity. Okay, that's very important identity. Okay, then let's try another way to let's try another way. Okay, so we have this, right? So that means I can replace n minus, okay, b, right? What is b? B is also n b minus 10a. So that, yeah, I moved it to here. Then I find out I get 10 equals na minus 1b and b minus 10. That's much better. Okay, why this much better? Because you think about that, this is a product, 10, right? Then you have a product to these two numbers. So there are not many choices for these two numbers, okay? And right, how to multiply 10, right? 10 could be 1 times 10, 2 times 5, right? And the 5 times 2, and then 10 times 1. Let's fully forget this. So then you will work on each of the case, okay? Case 1, NA minus 1 equals 1, and B minus 10 equals 5, equals 10. right? Just the first case. Then what you can get, okay? You will get NA equals, sorry, this is NA equals 2, right? And NB equals 20. Well, I think it's impossible. The reason is by the first equation. Okay, the first equation, n is integer, n just some integer because it's divisible, right? N is integer, n and a could be 1, could be 2, that's it, right? Right? And then because then the n is only either 1 or 2, but then n times b is just digits, so never be 20, so it's impossible immediately. So NA minus 1 equals 2, and B minus 10 equals 5. Right? So that implies NA equals 3, and B equals 15. Okay. And B equals 15. Okay. So from here, how many solutions you can get? I think the only solution I can get is n could be 3, a is 1, and then b equals n is 3, so b equals 5. Okay, you can think about that because if n is 3, a is 1. Okay, then b the other choice is n is 1. If n is 1, b cannot be 15. So n, right? So that's the only solution. But that's possible solutions. You have to find out. You have to use this equation. Okay, this equation tells you NB minus 10. So NB is a 15. Okay, so that's a 15. So that's a 5. Okay, and what is the possible value for M? What is the possible value for N? And I don't think we have a solutions here. Okay, so this will be 5n minus 5, and then 15 equals 4m, no solution. Okay, that's also exclude. But you can yeah, I derive some equations. Doesn't mean, this is this you can even plot them back to the original equation, but you can find out there's no solution. Case 3, NA minus 1 equals 5, and B minus 10 equals 2. Okay, in this case, you will get that's 12. Okay, maybe there's possible solutions, but let's go back to this equation. Okay, let's try to determine the m. So 10 minus m equals n minus 1. It's 12 minus 10, which is 2. Okay, I think I immediately get m. So what I get here is I get 3m equals 12, m equals 4. Okay, now m is 4. I determine the 4. That's very good formula. M since m is 4, so so we can find the possible value for a, and we just needed to find out NA equals 6 and B. Yeah. But how do we find the possible value for n? Okay. Then you go back to the original equation. trying to find out M is determined. That's great news. Okay, M is great. So M is determined. So let's try. Let's see. N, A, B. Okay, N could be 2, A could be 3. Right, that's the first case. N is 2, A is 3. N can be 1 or not. If N is 1, that's right. N cannot be 1. Yeah, let's try each of them. Okay, then N equals 3 and A equals 2. N equals 6. A equals 1. Okay, so we have to then try each of the case to see if we're able to solve the problem. Okay, so let's go back to the original equation. The equation is A. Yeah. No, that's impossible because NB is 12. That's already impossible. NB equals 12. Okay, that's impossible. Okay, from here, if N is 2, B is going to be 3. B is going to be 6. When here, you see, you have another equation B here. And when N equals 3, B equals 4. N equals 6, B equals 2. Okay, and then you just check them and go back to the original equation. So you only have a few 3 solutions here, and you do get 3 solutions in this case. Okay, so this is going to be let's see, 10A. That's, remember the original 3 equations. 10A plus B equals M. A plus B equals N AB, right? So let's check whether it's correct. So 10A, 36 equals 4 times A plus B, it's 9. Yeah, it's good. And it's also equal to 2 times AB, right? That works. Okay, then A is 2, so 24 equals 4 times A plus B, and 3 times A times B. Okay, then the other one is when A equals 1, so 1, B is 2, and M is 4, and 3, and N is 6, A times B is 2. So they all works. Okay, yeah. Okay, so the last case, we have to say NA equals 1, and B equals 10. All right, and this is a minus 1 equals 1 and minus 6. So that implies NB equals 11, and this NA equals 2. No, wait a minute. NA minus 1. Let's go back. Oof. No, NA minus, it's 10. Okay, sorry, it's 10. That to be 1. Okay, so so the question is whether it's possible, and then more likely it's impossible. Okay, so this is clearly it's a yeah, NA times, just NA equals 11. It's impossible. Okay, 11 is a prime number. Okay, so it's impossible. So we get three solutions. Wow, it takes too much time to find a solution. And those are the problems usually that give you 3 minutes. I have to do pretty fast and divide into several cases. Okay, it's not maybe you have some shortcuts, but that's how I get. Okay, I try to derive lots of identities from here, there, solving, and then I end up with this, and then like it very much. Okay, then you will see that there are not many choices for NA minus B and B minus 10. Okay. Right, now let's do the next one. Because there is at least one 2-digit number such that when it's added to the 10th digit number, having the same digits in the reverse order, the sum is a perfect square. Find all those numbers. Okay. Okay. So this is a question. 2-digit number. Okay. We're looking for this 2-digit number. Okay. When it is added to the 2-digit number, this 2-digit number having the same digits in reverse order. Okay, the sum is a perfect square. Clear? Okay. Find all such numbers. Two-digit numbers. Okay, we are looking for those 2-digit number have this property. When it's added to its reversed number, right? The number was reversed order. Okay, with the same digits but in the reverse order. The sum is a perfect square. So in other words, AB plus BA is a perfect square. And I want you to find AB. Right? So that is another type of equation. Yeah, and we're looking for such 2-digit numbers. This digit with the following property. When it's added to the 2-digit number having the same digits but in the reverse order, the sum added them together. So it's going to be a perfect square. We're looking for such numbers with these properties. Okay. There are some examples, such like, for example, 29. I just give example. 29 plus 92 is going to be what? It's going to be 121. It's 11 square. Okay. Yes. So this is one example. All right, so any ideas? Hmm? You got the 6 numbers? All right, so let's try, okay? So add them together, it's gonna be 10a plus b, right? And then 10b plus a. So this is gonna be 11a plus 11b, which means 11 times a plus b. Now this one to be a perfect square. But the a plus b, the largest possible value is 18. The smallest possible value is 1. Now it's actually 2 here because a, b cannot be 0. Otherwise, you cannot reverse order. Doesn't make sense, right? So that means between a plus b is a number between 2 and 18. But you already have a factor 11. So this becomes a perfect square. So the only choice for this is going to be 11, right? That's done. Yeah. So 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 a could be 2, right? B is going to be 9. Then you keep changing, right? Then all the way 8 equals 9 and B equals 2. Okay. So there are 8 such numbers there. That's my understanding. There are 8 such numbers. Okay. So it'll be 29, 38, 40, 47, yeah, 56, 60, right? 56, 65, right? And 74, and 83, and 92. Okay, all those numbers have these properties. Great. Okay, another similar problem will be find the or two-digit numbers with the following property. With the property that the integer is equal to the sum of its first digit plus its second digit. And plus the product of those 2 digits. Okay. So this is a 2-digit number. Okay, like that. So just write down, right? A, B, that's 2-digit number, equals the sum of the first digit, the sum of plus the second digit, plus their product. So that means you have a So B is immediately canceled out, right? And then 9A equals AB. You know what? Immediately you get B equals 9. Is there any restriction on A? I think the A is the first digit. It cannot be 0. So A cannot be 0, right? So the answer will be, it's 1, 9, 2, 9, 3, 9, all the way to 99. That's it. So that means this is a kind of discovery, right? You can determine all those numbers have this property, right? The two-digit number is going to be the sum of the first digit, second digit, and the product of the two digits. Okay, as long as B is 9, and it's necessary condition, B must be 9. Okay, B must be 9. Then you solve the problem. You get all the, okay. You see, in many cases, we express the two-digit number in the form like a 10A plus B. Got it? All right, so here's another question. We have 4 consecutive digits are used to form a 4-digit number. Right? A, B, C, D are used to form the 4-digit numbers. A, B, C, D bar. I put the bar there because it's not product. D, C, B, A bar. Okay. What is the greatest common divisor of all such numbers? Of the form A, B, C, D plus D, C, B, A. Okay. So, for example, like 1, 2, 3, 4 plus 4, 3, 2, 1, right? And that is going to be 5, 5, 5, 5. Yeah, you have to find the largest number. And that number you can divide all of such sums without the remainder. So that's why I call it the greatest common divisor. Okay, that's good. Anyone have answers for me? Hi, that's correct. Okay. So the idea is you have to use the same idea, right? A, B, C, D. It's going to be 1000A plus 100B plus 10C plus D. And the other one, DCBA, is going to be 1000D, 100C, 10B plus A. So the sum, I add them together, I will get let's see, 1000 A plus D, right? And 100 B plus C, and 10 C plus D, and then D plus A. Now, that's the problem here, right? But remember, that's a condition called 4 consecutive digits. Okay, 4 consecutive digits. The problem is that whether we can reorder them in a nice way. Okay, here A, B, C, D are used 4 consecutive digits, so they're in the order, right? They're in the order. So A can be, let's just assume A is B, A is N, B is N plus 1, C is N plus 2, and D equals N plus 3. Now, after you put them into here, what you see is you will get A plus D, right? A plus D is just 2N plus 3. And B plus C is 2N plus 3. And 10 C plus D is 2N plus C plus D. Wait a minute. C plus D. So I have this is not D, this is B. Okay, A, B. Yeah, B. C plus B is 3. Okay, then D plus A, it's also 2N plus 3. So that's just 2N plus 3, 2N plus 3. Okay, so then just common factor. So add them together, you take the common factor out. So it's get 1, 1, 1, 1. Okay, so but 2N plus 3, when n changes, you don't get the common. You don't get a common fact among those numbers. Okay, now there's a possibility A, B, C, D are not in the order. I think you will end up with the same result, okay? Because it's A plus D. A plus D, yeah, A plus D. But in this order, definitely clear, right? A plus D, and then B plus C, C plus B, and D plus A. They should have the same value, no matter how do you permutate them. Let's check that, okay? So we assume that, let's say A equals M, B equals N plus 2, C equals N plus 1, D equals N plus 3. Now let's see, okay? A plus D is going to be, A plus D is N plus 4. And then B plus C, wait a minute, A plus B plus C. It's not working. Yeah, B plus C is going to be N plus 3. And the 2N plus 3. A plus D. And that's a B plus C. And C plus, wait a minute, B plus C, C plus B. It's the same. And the D plus A. It's a still. Okay, in this case, it's not working. So my understanding is all those consecutive numbers in the order. Okay, it's not like you cannot change the order. So A, B, C, D must be in the order. Consecutive numbers cannot be changed.
Wait, well, from the A, it's just N, so it's kind of like A equals N plus 3.
Oh, N plus 3.
Yeah, so they're all equal to 8.
Oh, that's right. You're right. Okay, then it's working. Doesn't matter. So, from the problem itself, it's not very clear whether they must be in the order or not. Okay, A, B, C, D. Okay, but I just changed the order, still working. Okay, so 4 consecutive integers, digits A, B, C, D, it's not necessarily in the order, still works. Okay, yeah. Anyway, so the answer will be yeah, 1111. Okay. Okay. Here the next problem is still about 2-digit numbers. There's so many questions here. So the sum of the digits of a 2-digit number is 12. Okay. My question is, when the digits are reversed, the original number is increased by 54. What is the product of the digits? Yeah, I just want to find the number. Find the number. Okay, find this number. Find the origin number. Okay. Then of course you can find the product. Okay, so you already have the answers. Yeah. So you see, it's A and the B, right? That's 2-digit number. Okay, A and the B. The sum of the 2 digits will be A plus B. Okay. Now, if we reverse the order, so BA, so 10B plus A equals 10A plus B plus 54. Okay. So the second equation, let's look at the second equation. Okay. The second equation implies a 9B minus 9A equals 54. So you clearly get B minus A equals 6. Okay. So that's why you end up with these 2 simple equations. Okay. Now, if you add them together, 3B equals 18, so B equals 6. No. 2B, yeah. It's going to be 9. Yeah, 2B equals. Then A is going to be 3. Okay, so the answer is 39. Right? The answer is 39. So this is a not difficult problem. Right? That's not a good problem. Okay, my next question is, so we have 2-digit numbers, A, 5. The product is B times 1. That's 195. Do you remember this problem? Yeah, find A and B. Right. All right. So how do you solve this problem? First of all, guys, this is there are a couple ways to do. Okay. Now, 1995 is divided by 5. Okay. And then, yeah, maybe you should affect 1995 first. Okay. Yeah, if you find if you can fact 1995, 1995, and you should get a fact. One of the fact should be was the last digit is 1, then you solve the problem. Okay, you can try several digits. Okay, so this is a let me bring my calculator. Okay, I know the okay. So 1995, let's say divided by 5, right? 19. Okay, then it divides by 3, so I divide by 3. 133 times 3 times 5. It's not good, right? And then 133 is try 7, right? Just try 7. Then you get 19 times 7 times 3 times 5. So you complete the factor. Then once you factor this number, you can, which one gives you the last digit? Those two numbers give you that. Okay, so that's why it's going to be, actually 19 times 5 is 95 times 21. So the answer is, okay, so A is going to be 9, B is going to be 2. Okay, okay, let's work on the last part. All right, so the last problem is okay, I have a 7-digit number, 276 9A, 9A and 4 and the B. Okay, this 2-digit number, this is a divisible by 7. We're interested in 7. Okay, and find the A and the B if any. Okay, so you cannot just try that because they're not determined. How to determine the values A and B? Maybe you have multiple solutions so that this number divide, because we already learned how to divide. A number is divided by 3, divided by 9, divided by 11. We have the loops, but we don't have any loops for this. I'll give you 1 minute to think of it. All right, so the idea is this number is too large, right? You should A and the 4 and the B, you should express in the form, right? And plus 100A plus 40 plus B. I think I even can move 40 to the other side. Okay, 27690 40. I just needed this two, right? And oh, wait a minute. We that's right. So we get this number, right? This number divided by 7. Let's do this first. When you divide by 7, you find out the first part is divisible by 7. This number divided by 7. So so I got 7 times 395577 and plus 1 remainder. Okay. Am I right? The problem is, actually, my original problem is I mistyped. Original problem is A and B are the same digits. Let's solve this problem. Okay. So A and B. Okay. Let's look at this. Okay. Just need to make sure this is divisible. So 1 plus 100A plus B is divisible by 7. Okay. Is divisible. So this is a what? This is a basically that is a 200 as a 3-digit number, right? How many of 3-digit numbers you can have, right? That's a lot, right? So you just list all of them. Let's see. So the problem is make sure the last digit, right? It's 100, right? So this is actually A 0 and B bar plus 1. Okay, this should be divided by 7. So that so it's 100. This is a 2-digit number, but the largest possible value is going to be, yeah, no matter how to do that, right? The largest possible value, A0B plus 1, is less than or equal to 910. Okay, the largest possible. And the smallest possible value is going to be A is already there, right? A 1. And the 0, 1. B could be 1, right? So you just need to already list all of them and then the possible value for n. Okay, so you can list all of them. So that yeah, the smallest well, you cannot list all of them, but you can tell how many of them like that. But the original questions we assume A equals B. Okay, that's equals n, and then you can list some of them already. Okay, so let's see. We get oh, I got an idea. Okay, I got an idea. We can probably get all of them. Right? How do you do that? 100 is still too large, right? But you can divide by 7. 100 divided by 7. 100 divided by 7 is going to be the remainder. 7 times 14. What is the remainder? 2. Okay, great. So that's the reason. You see, the 100A plus B, right, is going to be 7 plus 14, right, and plus 2 and A plus B, and that's plus 1 here, right, plus 1. So you don't need to worry about this number. You only need to worry about 2A plus B plus 1, okay? And then this should be 2A plus B plus 1 is divisible by 7. and then it's easy to check. Okay, so I'm not going to, because we're over time, so we stop here. That's just many the few choices for the digits you can determine. Yeah, okay. So you just trim the larger number to a smaller number. Okay, use a remainder, then you can solve the problem. And here A is from 1 to all the way to 9, and the B is from 0 all the way to 9. Yes, there are lots of choices, but for each value of A, you can determine the value of B. There are only few choices. You can list all of them. Okay, I stop here.